Yeah, next part is more about logarithms. More about logarithms. So in this part, you're going to learn few new tricks of logarithm. For example, suppose you know that 2 cube is 8, right? What if I bring this 3 to the other side? Can I shift the power? We have done some similar solved example in part 1. If you remember that if at all I shift the power to the other side, I have to take a reciprocal of it. So I can write it as 2 is equal to 8 raised to 1 by 3. And that makes sense. Why does it make sense? Because anything raised to 1 by 3 is the cube root of that number. And cube root of 8 is 2. Right? So this is correct. Like if you shift 3 over to the right hand side, it becomes 1 by 3. So this is absolutely correct. Now try to understand this relationship in the language of logarithms. So 2 raised to 3 is equal to 8. How can I write in the language of logarithms? Log of 8 to the base 2 is equal to 3. Log of 8 to the base 2 is equal to 3. And how can I write this statement in the language of logarithm? Log of 8 to the base, I'm sorry. Actually, I have to write it first as 8 raised to 1 by 3 is equal to 2. So how can this be written? This can be written as log of 2 to the base 8 is equal to 1 by 3. This is 8. This is 8. Okay. So log of 2 to the base 8 is 1 by 3. Log of 8 to the base 2 is 3. Log of 2 to the base 8 is 1 by 3. Now do you find the pattern over here? What is the pattern which you find over here? The pattern is if log of a to the base b is equal to x, right? Then log of b to the base a will be 1 by x. If log of a to the base b is x, then log of b to the base a is 1 by x. Right? So that's a very beautiful pattern of logarithm which we saw here. And we can also write this relationship like this. I will show you here one more way. Sorry. Okay. See, what was log of uh, log of just a moment. Yes. Log of 8 to the base 2. It was 3, right? And log of 2 to the base 8 was 1 by 3. So I can say that therefore log of 8 to the base 2 is the reciprocal of log of 2 to the base 8, right? Or log of 2 to the base 8 is the reciprocal of log of 8 to the base 2, right? Now you can also understand this in terms of an identity. The identity says that, now I'm going to write the identity. The first identity of more about logarithms. It says that log of a to the base b is equal to 1 upon log of b to the base a, which also implies as log of b to the base a is equal to 1 upon log of a to the base b, right? So this is your first identity. And from these two identities, we can derive one more identity. So pay attention to this. So you can write it as log of a to the base b into log of b to the base a is equal to 1. This is actually the relationship which we get from the first identity. So this, let me tell you that it is the second relationship which we were looking for, right? Okay. So that was the first relationship which we saw. Okay. Now the second relationship. Can you tell me what is log of uh, a to the base a? Now, to know this, to solve this, we can equate it with a number x and then simplify it in the form of indices. So that means a raised to x is equal to a. A number raised to another number gives the same number, right? What could be x? Of course, x could be only one number, that is 1. Anything raised to 1 is the same number. So we understand that log of a to the base a is always 1, right? Log of a to the base a is always 1. Just imagine for an instance that I would write log of a raised to x to the base a. What would this give me? What would this give me? Log of a raised to x to the base a. Now you can use power law. You remember the power law from the second part of logarithm? Log of a raised to x to the base a can be written as x into log of a to the base a. Now what is log of a to the base a? We just saw log of a to the base a is 1. So this will become x into 1. And what is x into 1? X. So this is your third relationship. The third relationship states that log of a raised to x to the base a is nothing but x. Remember this. I can also give an example for the same. Log of 5 to the base 5 raised to 4. What will be the answer? 4. Directly using the above method, we can apply the formula directly, right? So that was your third law. Okay, fourth law. This is also very important. Uh, Suppose if I write log of a to the base b. Now I can simplify this log of a to the base b by writing it as log of a to the base x upon log of b to the base x. But the condition is a, b, and x all should belong to positive integers. All should belong to positive integers. Z means integer, plus means positive. A, B, and X all must be positive. So suppose if I want to find log of 3 to the base 2, it's easy to find it. How? I can write it as log of 3 to the base 10 upon log of 2 to the base 10. Why I have taken base 10? Why I have chosen 10 as my base? Because that is common logarithm, right? Now we know the value of log of 3 to the base 10 and log of 2 to the base 10. If I put those values, let me tell you those values from the earlier part. Log of 3 to the base 10 is 0.4771 and log of 2 to the base 10 is 0.3010. So I just have to solve this and get my final answer. Can be in fraction, can be in decimal, right? So this seemingly impossible logarithm could be solved using this identity. So this is nothing but the fourth and the new one, the fourth identity. I can give you one more example of the fourth identity. Log of 1000 to the base 10. Sorry, to the base 100. How can I simplify this? I can write it as log of 1000 to the base 10 upon log of, oh sorry, yes, log of 100 to the base 10. What is log of 1000 to the base 10? 3. What is log of 100 to the base 10? 2. 3 by 2 is the final answer. Seemingly impossible, right? Not common logarithm, but can be solved using this identity. This is the identity which is responsible, right? So we saw few of the new techniques of using logarithms, right? And we can now apply these techniques to our questions. Let's look at the questions now. Okay, the first question. If log of p to the base 10 is equal to 2a minus p. Okay, let me write it here. Log of p to the base 10 is equal to 2a minus b. Right? Express p in terms of x and y. Just a moment. X and y are the same. I don't see this question in my textbook. Oh yes, I see. I see the question, but it is not the same. Okay, so there is something wrong with this question. First of all, it is not part of the solved example, and second, it is part of an exercise, but I'm going to still solve it for you. Let me complete the question. Okay. Just a moment. Okay, this question is incomplete actually. I don't see the actual question. Uh, Let me check. No, it's not here. I don't see the question. Okay, let's move on to the next question then. Evaluate. Okay, the first one. Evaluate. Log of 625 to the base 125 minus log of 64 to the base 16. Let us evaluate this. Now I can use, see, I know the bases here are not favorable to us. So I can use the fourth identity, which we just studied. So it becomes log of 625 to the base 10, the whole upon log of 125 to the base 10 minus log of 64 to the base 10 upon log of 16 to the base 10. How can I write 625 in the simplest form? I can write it as log of, now 25 is a 625. So 5 raised to 4 is 625, right? If your multiplications are good. Log of 5 raised to 3 is 125 to the base 10 minus what is 64, uh, log of 4 cube to the base 10 and log of 4 square to the base 10, right? 64 I have written as log of 4 cube and 16 I have written as log of 4 square. Let's solve this further. So this will become 4 into, I'm solving this step, 4 into log of 5 to the base 10 power law upon 3 into log of 5 to the base 10 minus 3 into log of 4 to the base 10 upon 2 into log of 4 to the base 10, right? So log of 5 to the base 10 cuts from the numerator and denominator, and so does log of 4 to the base 10 in the second fraction. So it becomes 4 by 3 minus 3 by 2. LCM will be 6, 3 2s are, 2 3s are. So it will become 8 minus 9, right, upon 6. That is minus 1 by 6. So the answer is minus 1 by 6. Right, so this is how you solve the first question. Let's look at the second question. Log of 32 to the base 16 minus log of 125 to the base 25 plus log of 27 to the base 9. Nice. Now we know how to solve it. Fourth log. So it will become log of 32 to the base 10 upon log of 16 to the base 10 minus log of 125 to the base 10 upon log of 25 to the base 10 plus log of 27 to the base 10 log of 9 to the base 10. Okay, this you can write it as log of 2 raised to 5. 32 is 2 raised to 5 to the base 10 upon log of 2 raised to 4 to the base 10, right? 2 raised to 5 is 32 and 2 raised to 4 is 16. This you can write it as log of 5 cube to the base 10 upon log of 5 square to the base 10 plus log of 3 cube to the base 10 upon log of I'm sorry, log of 3 square to the base 10. Okay, this will become 5 multiplied by log of 2 to the base 10 upon 4 multiplied by log of 2 to the base 10 minus 3 into log of 5 to the base 10 upon 2 into log of power rule I'm applying, log of 5 to the base 10 plus 3 into log of 3 to the base 10 upon 2 into log of 3 to the base 10. Log of 2 to the base 10 gets cut, log of 5 to the base 10 gets cut, log of 3 also gets cut. So you are left with 5 by 4 minus 3 by 2 plus 3 by 2. Wow. So minus 3 by 2 plus 3 by 2 cuts, your answer is 5 by 4, which is improper fraction. So it will be 1, 1 by 4, mixed fraction. Right, so this was your question number 2. Let's do question number 3. Okay, we are going to do it over here. So question number 3, what does it say? Evaluate. Okay, you have to find the value 3 raised to minus 1 by 3 into log of 27 to the base 3. Okay, first write it as 3 raised to log of 27 raised to minus 1 by 3 to the base 3. Then 3 raised to log of 27 raised to minus 1 by 3. You know what is that? That is 1 upon 27 raised to 1 by 3 to the base 3. Because of the minus sign, I have taken reciprocal of 27. So it becomes 3 raised to log of. Okay, what is the cube root of 1 by 27? The cube root of 1 by 27 is 1 by 3 to the base 3. Right? Now, how to solve this? See, this is easy. What you can do is you can simplify this term separately. It is simplifiable. You can, okay, let's write it again. 3 raised to log of, can I write 1 by 3 as 3 raised to minus 1 to the base 3, right? And now can I write, see, remember this, I'm using this identity, using log of a to the base a raised to x is equal to x. You remember which identity is this? Third identity, right? So we have log of 3 to the base 3, log of 3 raised to minus 1 to the base 3. Now I can write it as directly 3 raised to minus 1, which is 1 by 3. Because minus 1 anyhow will get multiplied in front of the log. And then it will become minus 1 into log of 3 raised to 3. Log of 3 to the base 3 is 1. So minus 1 into 1 is minus 1, and 3 raised to minus 1 is 1 by 3. So this is how you can solve it. But in your textbook, what they have done is they have used a direct formula for this. So I would like to share that direct formula with you. So they have written that a raised to log of x to the base a is nothing but x. Remember this. So we could have, if we would have used this formula, which they have not described earlier, but now they are telling in the solved examples. If we had used, we would have used this formula, then the answer would have come very easily. So how could we use that formula directly? Over here, as you can see, we have a number raised to log of some number to the base of same number, right? 3 raised to log of 27 raised to minus 1 by 3 to the base 3. So when you have a number and you have the power in logarithm whose base is same as the given number, right? Then you can directly write it. You can just forget everything and directly write it as 27 raised to minus 1 by 3, right? So 27 raised to minus 1 by 3 is what? 27 raised to minus 1 by 3 is 1 by 27 raised to 1 by 3. And that is 1 by 3. Directly you get the answer. But since we used a little longer way to simplify it and then we got the answer somehow, we can also think of using this formula. But I leave it up to you. Don't force any formula upon yourself. Follow a method which you understand, which is easier for you. Don't stress for using any formula. Okay? Use correct formulae, less formulae but correct formulae. Don't memorize more formulae and then make a mistake in using it. Let's do one more question. So this is question number 4. Cube root of a, the whole raised to 6 log of 5 to the base a. Now, if you see closely, you have to apply the same identity as we used in the previous third question. See how I'm going to show it to you. I'm going to solve the whole thing and show it to you. Don't worry about it. Cube root of a. First, can I write cube root of a as a raised to 1 by 3? Yes. And then the whole raised to 6 log of 5 to the base a. Right? Can I write this as a raised to 1 by 3 into 6 in log of 5 to the base a? This everything is in power. Only a is the base. Now 3 gets cut with 6, you get 2, and you can simplify it as a raised to 2 log of 5 to the base a. Right? Now can you write it as a raised to log of 5 square to the base a. Now using, see I'm writing here, using a raised to log of x to the base a. Whenever you get this, what should be your answer? X directly, because the base over here is equal to the base of the logarithm which is in the power, right? So your final answer will be x. So here we have a raised to log of 5 square to the base a. So answer should be, the direct answer should be 5 square, that is 25. So now it should be very clear that how did we use this identity which I showed you in the third question. This part, the fourth and the miscellaneous, oh, there is no miscellaneous exercise, just one left, 8D. So 8D is going to be tricky for you, mark my words. And most of you are going to complain that the questions are very difficult and we cannot do it. I'm not taking that, okay? I've showed you the techniques. Now break your head. Now do whatever you can and try to get the solution. I want to see you struggling, because without struggle there cannot be any accomplishment. Nothing is easy, right? Let's see what is this. I have to zoom in maybe. One more zoom. Cool. If 1 upon log of x to the base a plus 1 upon log of x to the base b is equal to 2 upon log of x to the base c, through that c square is equal to ab. Now this is very clear. See, 1 upon log of x to the base a plus 1 upon log of x to the base b minus 2 upon, I'm sorry, is equal to 2 upon log of x to the base c, right? This is given to us. Can I write this as, log of a to the base x plus log of b to the base x is equal to 2 times log of c to the base x? Definitely, I can write it this way. Which identity have I used? I have used the first identity. Log of a to the base b is equal to 1 upon log of b to the base a, and vice versa, right? So if log of x to the base a is given, I can write it as 1 upon log of a to the base x. So again, if you take the reciprocal of this denominator, it comes in the numerator. That's what I've done. Now which identity will you use? You will use the product law. You remember the product law, right? Log of a to the base x plus log of b to the base x is log of a into b to the base x is equal to, here you will use power law, log of c square to the base x. That's it. Now these both terms are equal, so you can directly cut the logarithm. So ab is equal to c square. ab is equal to c square. C square is equal to ab. Proved. Hence proved. Chapter is over. Right? So the fourth part is tricky. You guys are like completing all the exercises within 1 hour and all. I'm seeing many students. That's really good, but that's not going to be the case with the fourth exercise, right? Because it's difficult. So, yeah. this is what we did today, more about logarithms. We did some identities, like log of a to the base b is equal to 1 upon log of b to the base a, and log of a to the base b into log of b to the base a is 1, right? So that was the first and second identity. Then the third identity was log of a to the base a raised to x is equal to x, and the fourth identity, uh, where is the fourth identity? Yeah, log of a to the base b is equal to log of a to the base x upon log of b to the base x. A, b and x, all three of them should be positive integers, right? So I'm just going to end this video now, and please complete the homework. I'm giving you 2 days time for the last exercise. See you later in the next video. Bye bye.